Okay, so remember when we are looking at equations with more than one variable in them, we cannot solve them with one equation by itself. Okay, so in junior cert already we looked at equations if we have two variables in something, so like x plus y is equal to 3. Okay, and we said if we have two unknowns or two variables in something like this, that we need to bring in a second equation. Okay, so we could have a second equation, something like that. Okay, and we would use our simultaneous equations, two equations, to solve for each of those two unknowns. Now here it is the exact same situation, but instead of having two variables or two unknowns, we now have three unknowns. Okay, so we have three unknowns, so we have three equations. Now, that is absolutely fine because we know from junior cert, again, if I had not gotten rid of this, okay, I would get rid of a variable using simultaneous equations with two of the equations. Okay, so I have two equations here. I could add those two lines together to get 3y is equal to 10. I could solve for y and then sub it back in. And it's the exact same thought process here. Okay, what we're going to do is we are going to label our equations A, B, and C so that they're easy to keep track of. Okay, and what we're going to do is we are going to take two of these equations and get rid of a variable, and then take a different two equations and get rid of that same variable, so that we're left with two. We've come up with two new equations with just two variables, and then we know how to solve for that variable, and we continue that process on. So these were our notes for simultaneous equations. You took these down in class. Okay, we need to look at the three equations together and see which of the three variables looks the easiest to eliminate. Okay, I'm not just going to go straight to eliminating z because I'm used to working with x and y or something like that if z isn't the easiest variable for me to get rid of. So then I'm going to bring two equations together and I'm going to get rid of whatever variable I've decided to get rid of. Okay, so looking at these three equations here. Okay, the x's. If I was to look at these two equations together, would it be easy to get the x's to have the same number in front? No, because I'd have to multiply this line by something and this line by something. Okay, likewise, these two equations together wouldn't be super easy. Okay, these two, if I was trying to get the same coefficient in front of the x, it would be okay. Okay, but it's still not super easy. If you compare it to the y's, okay, if I was trying to get the y's to cancel in a and b, all I'd have to do is multiply a by 2. Okay, likewise, I could take the equation a and c, and they already have the same number in front, okay, of the y's. So that's what we went through in class. Okay, how do we decide which variable we want to get rid of? Okay, and we said we wanted in this question to get rid of the y's. So remember how we do our simultaneous equations. After you've written out your equations, you draw a line underneath. Okay, that's how you're showing you go on to the next step. Usually, if you have something like 3x is equal to 9, okay, you just go on to the next step by going on to the next line. That doesn't work in our simultaneous equation stuff because we're already using more than one line per step. Okay, so you have to draw the line when you're going on to every new step. Okay, so we've decided here we're going to get rid of the y's. So let's look at two equations together. Okay, I'm going to show which two equations I am using by writing in their letters beside them. Okay, so you should be doing the same thing. Make it really clear which two equations you're looking at all times. Okay, so I'm just going to look at 2x minus y minus z is equal to 6. And I'm going to look at 3x plus 2y plus 3z is equal to 13. So the first thing you're checking for is, are they in the same form? Okay, so are the numbers on the same side of the equals? My constants are both on the right hand side. My x, y and z terms are all underneath each other. So line underneath for me to go on to my next step. Okay, now I want the same number in front of the y. Okay, so this has a 1 in front of it, this has a 2 in front of it. So I'm going to multiply that first line, my A line, I'm going to multiply it by 2. So every single thing in that is multiplying by 2. So that I get 4x minus 2y minus 2z is equal to 12. Okay, nothing has changed about the second line, but I'm writing it down again. Okay, think back to your maths. If you have something like 2 plus 4x is equal to, I don't know, 16 or 14. Okay, if you decide I'm going to minus 2 from both sides, you haven't changed anything about the 4x, you still write it down. Okay, it's the exact same thing here. I am not changing anything about the equation B, so I am still writing it down. So it's 3x plus 2y plus 3z is equal to 13. Okay, now you look at how can you cancel out the y's. Okay, so how do we get the y's to turn to 0? Well, they have the opposite signs, which means I can add the two lines together. Okay, so I'm going to add, I am showing that I am adding, okay, and then I will get 7x, okay, the y's will go to 0y, and then I have plus z is equal to 25. So now I have an equation with two unknowns, okay, two variables in it. Okay, I have just come up with the equation, 7x plus z is equal to 25. So I'm going to call that equation D. Okay, so I now have equation A, B, and C, and now I have equation D with two variables, an x and a z. Okay, so I have now got an equation with two variables, an x and a z. To solve for an equation with two variables, I need two equations. So I need another equation with x and z in it. So I'm going to take two other ones of these. Okay, I've already used A and B together, so I can't use A and B together, but I could use A with C, or I could use B with C. Let me just check my microphone is on. Yes. Okay, so whichever one looks easiest, I actually think A and C would be easier here. Okay, so that's the next ones that I'm going to do out. So A and C together. Now, you will get the exact same end answer if you were to have used B and C here, but it might look slightly different along the way. Okay, so we have 4x plus y minus 2z is equal to 3. So to get those to get rid of the y's, I just need to add the two lines together. Okay, so I'm going to just quickly, very quickly, line up my page so that we can see that I've moved on to a new step. Okay, so I'm going to add the two lines together so that I get 6x, sorry, I should be writing this in black, 6x, then the y's are 0y, minus 3z is equal to 9. Okay, so there is my new equation. And again, it's only in the variables x and z. Okay, so I'm going to call that equation E. Now look at E and at D together. I have two equations with two unknowns, so I'm going to look at those together. Yes, I have just written E down here, but I am still going to show I'm going on to a new step, and I am going to rewrite the equation E out so that it can be seen exactly what I'm doing and it doesn't look like I'm taking numbers from nowhere. So I have 7x plus z is equal to 25, and I have 6x minus 3z is equal to 9. Okay, so if I want them to have the same numbers in front of one of the variables, it's going to be easier here for me to match up the numbers in front of the z. So I'm going to multiply D by 3. Okay, so onto the next line, I will get 21x plus 3z is equal to 75. And I'm going to get 6x minus 3z is equal to 9. Okay, so the same number in front of the z's but with different signs, which means I add the two lines, remember. Okay, opposite signs, add the lines, same signs, subtract the lines. So we are adding these two lines. Okay, so I'm adding what's on the bottom there to what's on the top. So that I will be left with 27x, okay, plus 0z is equal to 84. Okay, so I'm going to need to divide by 27 to get x on a side by itself. Okay, so I'm going to divide by 27 so that we get x is 3. So 84 divided by 27, 3.1 recurring. Okay. So that is x. Seems a bit bizarre to have it a decimal this early on, okay, but I'll come back to that if we want to look at it a little bit closer. Okay, so at the end we'll look at how we verify and I'll be able to check did I get x correct, okay, because it's something that I'm not super sure of, so I will come back to it. But nonetheless, I have now found one of my variables. Okay, now, just like in normal simultaneous equations where there's only two variables, okay, I can find z now. Okay, so here. So I have D and E here. I can use either one of these equations to find z because I have x. So I can sub x back into one of my original, I'm doing apostrophes here. Okay, so one of the equations that has just x and z in it. And I can sub it back in to get what z is. Okay, so whichever of these equations look easier, okay, I think that D makes it look like it would be slightly easier to isolate z on a side by itself. So remember, every time you're rewriting out an equation, you are writing what letter it is. Okay, so I'm considering this as an original equation because it was one of the original equations that I made up. Okay, so I'm going to get 7 by my answer. So it's 3.1 recurring is what I found x to be. Plus z is equal to 25. Okay, see the way I don't round it? Because they never asked me to round it. Okay, now I want to get z on a side by itself. Okay, so it's up to you whether you want to do out that multiplication by 7 first and then move it, or if you want to just move it as is. Okay, I'm going to rewrite it as 21.7 recurring plus z is equal to 25. Okay, and then let's subtract that from 25 so that we get z to be 3.2 recurring. Okay, so now I have z. Okay, because I'm unsure of my answer, I'm going to go straight into just checking would this have actually worked out. I'm going to verify my answer for x and z, even though I should wait until the very end and verify all three together. I'm just going to verify this quickly just to make sure. So just think about it as if I was looking at simultaneous equations with two variables. So from where I've found D and E here. Okay, so from where I found D and E, I've just been looking at simultaneous equations with two variables. I found my second variable by subbing into D. So to verify my answer, I'm using the other original equation. Okay, so I'm just going to verify what I have done as much as I can verify, just because I'm slightly unsure of my answer here. I feel like I might have made a silly mistake somewhere. Okay, so I'm just going to verify using the other original equation. Okay, again, apostrophes around original. Okay, it is something that I came up with. So it's going to be 6 times 3.1 recurring minus 3 times 3.2 recurring is equal to 9. So let's see. So 6 by 3.1 recurring. Minus 3 times 3.2 recurring. We get 9. Okay, great. So 9 is 9. So that would be verified if it was simultaneous equations with two variables. Okay, so it's given me a little bit more confidence. It doesn't mean I definitely have gotten it completely correct. Just it's given me a little bit more confidence to keep going. Okay, so now I have two of the variables. Okay, I have x and I have z. So now I'll go back to one of my very original equations where y is also included, and I will decide which one do I want to sub in for to get y, and I think C looks like the one that's going to be the easiest to isolate y in. So I'm going to sub back into C. Okay, so first I'm just going to write C out again. So minus 2z is equal to 3. And then I'm going to sub in. So I have found x is 3.1 recurring plus y minus 2 times 3.2 recurring is equal to 3. Okay, so we need to rearrange to find y. Okay, so 3.1 recurring by 4 is going to be 12.4 reoccurring plus y minus 6.4 reoccurring is equal to 3. Okay, so y plus 6 is equal to 3. So when we take 6 from each side, y is going to be minus 3. Okay, so now we have found each of them. Get a highlighter or get a different colour pen, not red. Okay, because remember you're not using red in your exam. And highlight each of your answers or draw a box around them. Okay, so to verify now, to fully verify, I can choose one of my other original equations, so A or B in this case. Okay, so I'll just use equation A. Okay, so I have 2x minus y minus z is equal to 6. So I'll sub in. So 2 by 3.1 reoccurring minus a minus 3 minus a 3.2 reoccurring is going to be equal to 6 if I have gotten this right. So we will get 6.2 reoccurring plus 3, so 9.2 reoccurring minus 3.2 reoccurring is 6. So 6 is equal to 6. Okay, so that's my simultaneous equations verified as well. If they ask to round, make sure that you still write your answer before rounding and then in the next line round.